All right. We are going to go over our term 1 exam review pretty quickly. I'm going to try and get this all in so you're not sitting here at the TV or the computer screen for a while. So, function notation, remember this is just another way of putting y. So y equals, so if we write it in function notation, it's f of x equals y. Domain are all your x values, range are all your y values. Okay, so the first thing we need to know is we need to circle and determine whether or not a relation is a function or not and explain why. So your first graph is a function because it passes the vertical line test. So you would say function and then passes the vertical line test. Your second one is not a function because there's two arrows coming from an x value. So I know it's just listed once, but because there's two arrows coming from our 0, this means we have an ordered pair of 0, 2 and 0, 3. Therefore, the x values repeat. Okay. All right. The third one, all of your x values are different. So therefore, this is a function and it's different. So it's because all the x values are unique. On the third one, or the fourth one, sorry, you're going to plug it into Desmos to graph it and see if it passes the vertical line test. Okay, so what I mean by that is you're going to go here. Desmos. And then you're going to type in f of x equals 2x plus 8. And it does pass the vertical line test. Okay, so therefore it is a function. Okay, so you will have one of those on your test that you need to be mindful of, that you're going to be able to use your Desmos calculator on the testing. All right, evaluating functions. So when we evaluate functions, this means that they are giving us x. So they're giving us the value of x. Okay, so this says f of x equals 5x minus 9, f of negative 3 divided by 5. So this means x equals negative 3 divided by 5. So wherever there's an x, I'm going to put negative 3 divided by 5 minus 9. Okay, so if you type that into your calculator, so 5 times negative 3 divided by 5, JK. And then minus 9, we get negative 12. Okay, so that would be our answer there. So this will be negative 12. Same thing here. Okay, I'm not going to actually do it in the calculator, but again, wherever there's an x, I can put negative 21. So it's 3 divided by 4, parentheses, negative 21 plus 5. If you type this whole thing into your calculator, you should get negative 12. Okay, so this means there's an ordered pair at negative 21, negative 12. Okay, so understand what you're finding there. You're finding an ordered pair that's on that function. So speaking of ordered pairs, this one right here says, what is the value of the following? Okay, so this means when x equals negative 7, I'm wanting to know what is y. So you would go to negative 7 on the x-axis. That's negative 8, negative 7. And then luckily for you, your ordered pair is at 0, meaning you're trying to go find where the graph is. And in this case, it is on the x-axis, so it's just 0. So this next one, it means f of 4, so it means x equals 4. So I'm going to go to the x-axis at 4. And then I'm going to try to figure out where is the graph. Well, the graph is here, and that's 1, 2, 3, 4 units up. So our answer is 4. Because there's an ordered pair here of 4, 4. All right. All right, this is the one I want to spend the most time on. So determine the domain and range of the following relations, then explain it using words. So one, you have to understand the difference between discrete and continuous. So this first graph of ordered pairs is known as discrete because it is disconnected value. So when it's disconnected, it is known as discrete. So when it is discrete, all you have to do is list out your ordered pairs. So this one is -1, 1, 0, 3, 1, 2, 2, 1, and then 3, 3. Then when you list out your domain and range, remember it's least to greatest, and then if you have repeats, you only write it once. So our least x value is -1, then 0, then 1, then 2, then 3. And then your range are all your y values. So in this case, 1. We have another 1 right here, but we only have to write it once. 2. And then we have 2 3s, so we just write it once, so we have 3. And that's your domain and range. Your domain and range of this one will look a little different because this is a continuous function. Okay, continuous means we're going to say it's between this number and this number. Okay, so our domain is left to right. So I go to my furthest left point and I'm going to follow it to the x-axis because your domain are all your x values. So it starts at -7. My inequalities, remember, always face the same way, and x goes in the middle. Then I go to my furthest right point and follow it to the x-axis, which is at 0. You do need to decide if one of your if one of your sides needs an equal to sign. Okay, so because the one that's even to 0 is closed, we're going to put an equal to sign there with the 0. So how you would write this in words is you would always write all real numbers. Okay, but you need to make sure you're using it in the perspective of the variable. So it's all real numbers, and then the first number we're going to say is always the least number, the smallest number. Just like when you write it, it's always smallest to greatest. Okay, so x, and this sign is opening to the x, so that's a greater than sign to the x, -7. So we're going to say all real numbers greater than -7. Okay, but the highest point is 0. So how I would write that is less than or equal to 0. Okay, so n less than or equal to 0. All right, my range is from bottom to top. So I go to the bottom point and see where it's even to on the y-axis. So in this case, it starts at -3. Inequalities face the same way. And then the top point is even to 4. Okay. Because the -3 is the closed endpoint, the -3 inequality will get the equal to sign. So again, when I write this, I always start off with all real numbers. Okay, but now I need to write it in the perspective of y. So all real numbers greater than or equal to, because this inequality is opening to our y, -3. So it's greater than or equal to -3 and less than 4. Because that's a less than sign in perspective of the y. Okay. All right, so domain, again, is left to right. So I go to my furthest left point, follow it to the x-axis, and it's at -1. Inequalities face the same way. But then I go to my furthest right point, and it's an arrow. So anytime it's an arrow, that means it's going to go in that direction for infinity, right? It never stops, okay? So usually they do not write it in this form though. They will never usually put infinity, right? So although that is right, okay, they won't put this part of our graph. So really our answer is just this right here. Okay, so x is greater than -1. But we usually always want to put our variable first if we have the opportunity. Okay, so it's x is greater than -1. So this is your answer, but this is also your answer. It's the same thing, okay? Because infinity numbers, okay, infinity is going to be greater than -1. So it's all real numbers greater than -1. So we do this so we don't get confused with our signs, in which way our sign should face, okay? So because I'm just writing this part, my inequality should open up to my x, okay? So my range is bottom to top, but I go to the bottom and it's an arrow, and I go to my top and it stops at 3. So because my arrow is pointing down forever, okay, I'm going to put negative infinity on this side. Inequality faces this way. Y goes in the middle. Inequality faces that way always. And then the top of the graph is 3. So the range is all real numbers that are less than 3, okay? Because, remember, we won't put this part. We will just use the y is less than 3 because negative infinity is always going to be less than 3, right? So it's all real numbers less than 3. So again, this is still your answer, but you're going to see it mostly like this, okay? Probably all the time. All right, domain. I go to my left, and it's an arrow. I go to my furthest right, it is also an arrow. So this means it's negative infinity to infinity. And usually you will not see it this way. What they will say, it is just all real numbers. And this is the symbol for all real numbers, by the way. So it's all real numbers. Your range is bottom to top. So I go to my bottom, starts at 1. Inequalities face the same way. Go to my top, and there are arrows. So when there are arrows, that's infinity in that direction. But like I said, you will not put the infinity part of it. So really our answer is just y is greater than 1 because the inequality needs to be eating the y. So our answer is all real numbers greater than 1. Greater than or equal to, by the way, greater than or equal to 1. Because the line hits -1, so therefore we can include it. That's my fault. All right. All right, so I'm going to do one from each of these sections, okay? So I'm going to do the opposite one than what we did in class. So number 2, okay? So I'm going to move, every time I'm solving for y, I need to move my x to the other side. But when I do that, I do the opposite sign. So I'm going to add 4x. But when I add 4x, I cannot physically add -18 and 4. One's a variable, one's a constant. Okay, so what I have left is a positive 6y, -18 plus 4x. And then my last step is to divide by the coefficient on y. So I'm going to divide by 6 because that's the coefficient on y. But I divide everything by 6. So y equals -18 divided by 6 is -3. And then 4 divided by 6 is a positive 2 over 3x. And this is your answer. Okay, so just remember, when you move your x to the other side, you're not physically going to add these numbers because you can't, right? And then x just doesn't go away. It goes away from this side, but what I'm doing is putting it on the other side so I can get y isolated, okay? All right, solving equations. So I'm going to do the same two questions that I did in class today, Okay, so it's important to me that we're able to do all the steps, including, okay? All right, so number 2, okay, we have negative 11 plus 10 times x plus 10 equals 4 minus 5, 2x plus 11. So our first step is to always, always, always distribute. Okay, so let it be known that we're distributing also the sign in front of the number. Okay, so I'm actually distributing a positive 10 here, so it'll be positive 10x. And then positive 10 times positive 10 is a positive 100. Negative 5 times 2x is a negative 10x. And then negative 5 times 11 is a negative 55. Bring down what I didn't use. So I didn't use this 4, and I didn't use this negative 11. I now want you to label your constants and your variables. So we have a constant here, variable, constant, constant, variable, and a constant. Therefore, we know what we need to be moving and combining, okay? So on the left-hand side, I want to combine the negative 11 and the 100 because they're both constants on the same side. Remember, we're on the same side of the equation. We do not change the sign of them. So this now is 10x, and then negative 11 plus 100 is a positive 89. I am on the right-hand side, I'm going to combine 4 and a negative 55, because remember, we got to use the signs in front. So what I have left is a negative 10x, because that is a negative 10x, and then 4 plus a negative 55, or 4 minus 55, is a negative 51. Okay, so again, label your constants and your variables if you would like. I am now going to move my variable to the left. So I'm going to add 10x. The reason why I'm adding is because the moment I have to jump across the equal sign, I have to do the inverse. Okay, so 10 plus 10 is 20x plus 89. I'm bringing down what I didn't use. Negative 10 plus 10 is 0, so I don't have that left. And then I have a negative 51 left. Don't forget to bring down the sign with it. Okay, it's not just the 51 that gets brought down. It's also the negative sign. All right, now I need to move my constant, my 89, to the left or to the right. So I'm going to subtract 89 because I'm moving across the equal sign. What I have left is 20x. And then negative 51 minus 89 is a negative 140. And then when I have my variable on the left and my constants on the right, I divide by the coefficient. So when I divide negative 140 by 20, I get negative 7. Okay. All right. So again, these over here, you're going to end up doing the same steps. We just need to be mindful of bringing down our signs. Okay. All right. Number 6. Okay. It's an inequality. So remember, when there's an inequality, your steps are the same. Okay. We just have that one rule at the end. Okay. So negative 5 times 2 is negative 10x. Negative 5 times positive 7 is a negative 35. Bring down what I didn't use. Label your constants and your variables. So variable, constant, variable, variable, constant. Combine those that are the same. So I have my negative 10x and my positive x. Well, remember, that's like a 1. So really what I have is negative 9x. Okay, I'm going to move my variable to the left. I'm going to add it over because I'm going across the equal sign. So what I left is a negative 8x. Minus 35 is less than negative 11, because remember, you got to bring the sign down with it. I'm then going to move my constant to the right, so I'm going to add 35. Okay, I'm left with negative 8x is less than. Negative 11 plus 35 is a positive 24. And then I divide by negative 8. So here's the kicker. Remember, when you divide by a negative, you must flip your sign. So that is now a greater than sign, and x is greater, every number greater than negative 3. Okay. All right, and your work and stuff will be done on the Google Classroom post for number 1 and number 5, okay? So it's not just going to be empty. I do have work shown. All right, last 2 problems, okay? All right, so simplify. When we simplify, it's because we do not have an equal to sign or an equal sign, okay, or an inequality. So the only 2 things you can do when you see the word simplify is distribute and combine, and that's it, right? So I don't have anything to distribute here because I don't have numbers in front of the parentheses other than a positive 1, and there's no sense in distributing a positive 1. So after that, then you just start combining your like terms, and I mean they have to be exactly alike. So I always start going from left to right, okay? So the first thing I'm going to try and find are all the x squareds. So I have an x squared there, and then I have a 5x squared here. So when you find your terms that match, you just add the coefficients. So 4 plus 5 is 9, so I have 9x squareds. I then move on to the next one. So once I go through all of my x squareds and I combine them into one term, then I move on to the next one. So this next one is xy. So I'm looking for everything else that is labeled with xy. So I go through and I'm also label this positive 2. So notice I'm also taking the sign in front. That is not a 6xy. That is a negative 6xy. So when I'm combining them, it's negative 6 plus 2. And what you get is a negative 4xy. Then I move on to the next term. So I have y, but that is my only y. So I just put it right next to it. I only have 8 y's. And then last but not least, let's throw a green in there. Okay. And then I have my constants, right? So I have negative 1 plus 7. And when I do that, I get a positive 6. And that is my answer. It's okay that you do not have a value as your answer because you just combined all the like terms, and that's all you can do. You don't have an equal sign, so you can't get a value. Okay. This one, perimeter, remember, is adding all the sides. Okay, so I'm adding. So I have y plus 5 plus y plus 2 plus y plus 3y minus 2. Right? I added all the sides. Well, ideally, it's the same thing. All my y's are together. So all together, I have 3 plus 4, or 3 plus 1 is 4, 4 plus 1 is 5, 5 plus 1 is 6, so I have 6 y's all together. And then I have my constants. So 5 plus 2 is 7, and 7 minus 2 is a positive 5. So my perimeter of this shape is 6y plus 5. And it's okay that you do not get a value. Okay, there will be a separate video of me going over the big problem. All right, bye guys.